Welcome back. So, in last part we have started the hydrogen atom. We have written down the expression for Rn and Fen, the energy and the radius. So, from there we will carry forward. Okay. So, first is radius of not R, okay, it is nth orbit, or let us say more specifically Bohr orbit, because this concept was given by the great Niels Bohr. Okay. Okay. So, what was the form? Rn was epsilon naught n square a square. What is epsilon? Electrical permittivity in free space or vacuum. So, the value is 8.854 into 10 to the power minus 12 Coulomb square Newton inverse meter to the power minus 2. Rest h is, I am not writing, Planck's constant. Oh. Okay. Next, mass of electron, that is 9.1 into 10 to the power minus 31 kg. All are the in SI unit. E is the charge of electron, that is 1.16 or not 1.6 in 10 to the minus 19 joule. Coulomb, not joule. Okay. So, this is the values. Pi is constant. So, from here we can see that except n, everything is constant, right. So, we can write it a naught n square, everything is constant. So, a naught should be constant, So, what will be the value of a naught? A naught is epsilon a square divided by pi m square, very important. Okay. What is a naught? I will come into that, but it is clear that a naught is constant. And what will be the value? If we put these values here, then we can obtain that a naught is 0.53 into 10 to the power minus 10 meter. Okay. We can discuss the dimension. The value we can put in calculator, that is easy, but now if for epsilon the dimension is Coulomb square Newton inverse meter to the power minus 2. For h square is joule second, so it will be joule square second square. Pi is dimensionless. M, mass of electron, is kilogram, charge is Coulomb square. So, Coulomb square will be cancelled out. Okay. Now, joule, what is joule? Joule is Newton meter. So, joule square will be Newton. So, let me write it. So, Newton inverse meter to the power minus 2. So, it is Newton meter, Newton square meter square second square divided by kg, but this kg should be cancelled. Okay, let me see. Okay, Coulomb square, it's correct. I think there is no mistake. Okay, so now meter square will be cancelled, and it is Newton, 1 Newton is there, second square by kg, right. This is the unit. Now, what is Newton? Newton is force means for force, mass into acceleration, mass kg, acceleration is meter minus 2. So, if we put this, then it is kg meter second to the power minus 2, 1 second square is there, kg is also there. So, kg cancel, second square cancel, meter. Okay. So, meter is here. This is the unit analysis. So, for A0, the value of A0 is 0.53 Armstrong, or we can write it 0.053 nanometer. Okay, very very important. You have to remind this the value. Two value you have to remind. First one is this A0, and okay, Armstrong. Armstrong is 1 Armstrong is 10 to the power minus 10 meter. So that's why this is directly you can write is 0.53 Armstrong, and 1 nanometer is 10 to the power minus 9 meter. So that's a 0.053 nanometer. So this is the value of A0. Okay. Now what is A0? That we have to evaluate. It's easy. Let's see. So what was the form? Rn equals to A0 or A naught. A naught is more correct. A naught into n square. This is the expression. A naught is constant. Let me write it here. So now for first orbit, n is 1. So R1 should be A naught. So A naught, we have evaluated the value of A naught, the form of A naught. This A naught is actually called first Bohr orbit radius or first Bohr radius. So this is the radius of the first Bohr orbit. Okay, this first orbit is also called K cell of the atom. Okay, so the radius of K cell is A naught or the Bohr radius. Okay, so this is very important. This is now for second. For second orbit, R2 should be 4 A naught. It's easy. We have just put n equals to 2. So it's also called L cell. Okay, and now it goes on. For R3, it should be 9A0, A naught, 16 A naught, and so on. It goes up to infinity. But basically, we'll come into that. We are actually considered up to 6th or 7th level. 7th orbit. It is actually KLM cell or M orbit. Orbit also correct. This is N orbit or cell. You can write it. So and goes on. So this is the case. And what is the values? What are the values? These values is just we have to multiply 4 into 0.53 Armstrong. So it should be, what is this, 2.12 Armstrong. For these the value is 4.77 Armstrong, etc. Okay, so this is the case. So now if we draw it, so there is one proton, that is the nucleus. A first orbit, that is the radius should be A naught. The second one, this radius is A naught. This is the A naught. Okay. For the second one, this should be the 4 A naught. That means 4 times. So like here, it should be circular. Okay. This is the second orbit. For third, it should be 9. So it will be not okay covered in this page, but we can see. So we have to draw, but we are not follow the scale. Actually, we have to just understand. So it is A naught, it's 4 A naught, it's 9 A naught, it's 16 A naught, and goes on. This is first Bohr orbit, which is K, L, M, N, like this. So this is A naught, this is 4 A naught, this is 9 A naught, this is 16 A naught, and so on, so on. Okay. So these are the orbits. So now according to Bohr's postulate, first that electron can be here, electron can be here, electron can be here, electron can be here, but electron cannot be in between these two. So electron can't have the radius in between 0.53 Armstrong or in 2.12 Armstrong between these two. or between 2.12 angstrom or 4.77 angstrom. This was not allowed according to Bohr's postulate. So, this is the case. Okay. So, from here we can understand the discreteness. Each energy level is not, each radius is not allowed. There are some specific radius that are allowed, which are a naught n square. These radius are allowed. So, that is why this n actually determines the allowed radius, the orbits. That is why it is called the principal quantum number. Due to n, the quantization appears. So, that is why n is called the principal quantum number, very very important. Okay, the energy. Energy of the electron. Okay. En, let me write it En, the energy of the electron in nth orbit. So, what was the form? This was the form, right? But this form obtained putting the value of Rn. So, let me do it from scratch. So, it was okay. So, 1 by 4 pi epsilon naught Z square by 2 Rn. This was the form. Okay, this was the form. For hydrogen atom, Z is 1. So, we can write it. Okay. This is for hydrogen atom, and we know that Rn is n square a naught. So, if we put it, then we obtain a naught n square. So, exactly. So, this is the form. This form is directly written in books, but this is the form of, this is the, let me write it, energy of electron in nth orbit. Okay. So, in principle also here n can goes up to infinity, and we can see here all the part except the n square is constant. So, we can write it also En proportional to 1 by n square, as here Rn is also, we can write it direct n square, but energy is also proportional to inverse of n square. Okay, n to the power minus 2. Okay. Now, for ground state, for n equals to 1, okay, that must be the ground state. Why? We will see it. So, E1 should be E square by 2 a naught. So, this is the energy of the ground, energy of the first state. So, we can see here that En is something. Now, if n is increasing, first we understand, if n is increasing, but rest are the fixed, rest are the constant. If n is increasing, then overall part will be, overall En will be increased, will be decreased, because En is something into 1 by n square, right? This is the form. So, if n increases, then this is decreases. So, En should decreases, but there is a minus sign, there is a minus sign here. This is the minus sign. So, as there is a minus sign, so En should be En should be increased if n increased. So, if n increases, then 1 by n square should be decreased. If 1 by n square should decrease, then En should be increased, because there is a minus sign. Okay, it's clear. Okay. So, now let me erase it. So, from here it is clear that if n increases, as it is proportional to n square, n to the power minus 2, we can say it. So, it should, if we plot the En and the n, then this plot should be like, as there is a minus sign. So, I am not sure, but it should be exponential, right? Not like this. It should goes, must not stay in, not in straight line, because n square is there, it is not linear. Okay, I am not sure about the nature of the curve, so not getting to that, but En should increase. So, En should increase. So, when n is 1, then En should be least, E1 should be least. Now if n increase, then E2, so it's E2 must be greater than E1, then E3 must be greater than E2. From this relation we can write. That's why the energy of the ground first orbit E1, that should be the minimum, that should be the least energy. That is the reason it's called the ground state. Ground state means the state having the least energy. That's why it's called the ground energy state, okay, of hydrogen atom. Actually it's ground state energy. What is the value? If we put, everything is constant, right? So if we put, then we obtain it is minus 13.6 electron volt. Very another important, we have to also remind this thing. Two things we have to remind. First is A0 or A0, value of A0, and second one is this. And if we remember 1 electron volt, what was 1 electron volt? 1.6 into 10 to the power minus 19 joule. So this is the energy, you can see it's very less. So this is the energy of the first state or the ground state of the hydrogen atom. Okay, so it's okay. Now we can do some things. We can put the value of A0. What was the A0? What was the A0? A0 was epsilon naught h square pi m square. Epsilon naught h square pi m square, and E1 was 4 pi epsilon naught E square to A0. If we put the A0 here, then we should obtain E square pi, okay, let me write it here, 2 epsilon, not epsilon, it should be epsilon naught. So it should be epsilon naught h square pi m square. So pi will be cancelled, so it must be m e to the power 4 8 epsilon naught square h square. Yes, correct. So this is the case, this is the energy. Okay, so now we can write it. Okay, we can write it like m e to the power 4 8 epsilon naught square h square, then or ch cube, then we can multiply ch, yes, in this way we can also write, right? We can multiply the hc and divided hc, then it will be, this is called r ch. Okay, this is called, this part is called Rydberg constant. Okay, let me see the spelling. Yes, right, Rydberg constant. This is constant because m is the mass of electron, constant, E is charge of electron, constant, epsilon naught constant, c constant, h constant, all that constant. So it is, this E1 also constant, right? This should not change because r ch, but r is Rydberg constant, which is r equals to m e to the power 4 divided by, this is very important, numerical question can be asked using this relation. Okay, so this is very important, this is the Rydberg constant, and the value is, if you can remember then it's okay, but it's not, it's better to remember. Okay, it's good. R is 1.09737 10 to the power minus 7. What will be the unit? That's the case. Let's then find out. M is mass, that should be in kg. E is charge of electron, coulomb to the power 4. Epsilon naught. What was the unit of epsilon naught? Yes, that is coulomb square Newton inverse meter to the power minus 2. So coulomb square Newton inverse meter to the power minus 2 whole square then c is speed of light, that is meter second inverse, and h cube, so joule cube second cube. So it should be coulomb to the power 4 minus 4, and this should be n to the power minus 2. Okay, so now what will be the unit? C to the power 4, C to the power 4 will be cancelled out, and it will be, let me write it here, kg divided by Newton square meter to the power minus 3 joule cube second to the power second square, right? Now joule is Newton meter, so it can be written as Newton cube meter to the power meter cube. So this will cancel out. Okay, it is minus 1 minus 2, so it will be kg divided by Newton second square, kg Newton second square, and Newton is kg into meter second to the power minus 2. So if we put it here, then let me erase this part, then it will be kg divided by kg meter second to the power minus 2 second square. So it should be the meter inverse. Yes, it is the meter inverse, the unit is meter inverse. So I am erasing this part, it should be done by yourself. So this is the unit of read by constant. So in this part let me stop here. In next part we will carry forward from here, and we will evaluate the speed of electron in nth orbit, and also we will discuss the ionization energy concept. Okay, so let me stop here, we will continue from here next part. Thank you.